Good afternoon, everybody, and welcome to our panel session on energy and resources, powering the next phase in space exploration. My name is Dina Santos, and I'm the head of our Canadian Trade Office here in Dallas, and it's my great honor to co-moderate this panel today with the New Mexico Economic Development Department. The Trade Commissioner Service is a free business development service with the mandate to help Canadian exporters explore global markets. We are we have offices of about 160 across all the world, with 6 regional offices. And in the U.S., given the importance of the trade and investment relationship, which is over $1 trillion, we have over 14 offices, including our embassy in DC. The U.S. is the first market of choice, typically for our first exporters. That's why the renewal of our U.S. Canada-Mexico Free Trade Agreement was so important. And if you look at our region, we basically cover 5 states, the states of Texas, Arkansas, Oklahoma, Louisiana, and New Mexico, would represent a population equal to the one of Canada with a similar GDP. In terms of the space sector, we certainly have a lot of American and foreign multinationals that call this region home. And our Canadian Astronaut Corps resides at the NASA Johnson Space Center in Houston, Texas. We have 12 out of the 12 US FAA commercial spaceports, 4 are in region, including 1 in New Mexico. And speaking of New Mexico, a state that we cover, they're really cutting edge in terms of research regarding the next phase in space exploration. One of our roles here at the Canadian Consulate in Dallas is to connect industry research institutions in local markets with Canada. We've partnered with New Mexico Economic Development's Office of Science and Technology Department today to bring this panel to the Canadian Science Policy Conference, a means by which to exchange information and identify opportunities of mutual interest to strengthen the ties and build new ones between New Mexico and Canada. With that, I'll turn it over to my co-moderator, Dr. Myrriah Tomar, who is the Director of the Office of Science and Technology for the New Mexico Economic Development Department. Myrriah will provide a brief overview of New Mexico and set the stage for the upcoming panelists. Myrriah and I will then return at the end of the session to co-moderate a Q&A and wrap up with some final thoughts.
Thank you, Dina. Can you see my slides? So good afternoon, everyone. As Dina said, I'm with the State of New Mexico Economic Development Department. I'm very excited to be here with you all today and to share our panelists and some of the exciting research projects in advanced energy research as well as deep space missions. My hope is that today, after hearing today's talk, that you will be inspired to engage in future collaborations between our institutions here in New Mexico. I also want to thank both Dina, the Global Affairs Canada, and the CSPC for the opportunity to co-moderate today's session. So I'll just start by giving you a brief overview of the Economic Development Department. We are a state agency that provides direct assistance to New Mexico businesses and communities. We have a variety of departments within departments and divisions, of which I lead the Science and Technology Office. We also have an International Trade Office and a Finance Development Office. So for businesses that are interested in participating in trade missions or working with anyone outside of the US, our International Office, Trade Office deals with that. So as Director of the Office of Science and Technology, I wear several hats. I work directly with the science and tech businesses. We help them to identify funding. We educate them on tax credits and business incentives throughout the state. And in addition to this, really my role within the economic development is to build strategic partnerships throughout the state, both with the private investment sector, as well as our public university and national laboratory tech transfer offices. Finally, I work with the state to generate and advise on legislative policies related to science and technology. So, for example, this past legislative session, we created 4 centers of excellence, which are industry clusters that were identified by our governor as important hubs of science and technology in the state. In addition, we worked with both Sandia National Lab and Los Alamos to generate legislation that would help entrepreneurs receive technical assistance for the lab with for up to $150,000 for those that have an active license or CRADA with the lab. So those are just a few of the things that we do at the state agency office. Many of you may be familiar with New Mexico or heard about us, but we're often called the land of enchantment. This is in part due to the fact that we have a really diverse culture here. We have great outdoor recreation, and we have these kind of world-renowned festivals. However, aside from being kind of a tourist destination, I think more importantly, and what I hope you get out of this session today is that New Mexico is really doing some amazing science. Our state is at the forefront of scientific research, and we also happen to have the highest number of PhDs per capita. And so it's been since 1945 that New Mexico has been a leader in energy research and development, with extensive experiments being conducted both at Los Alamos National Laboratory as well as Sandia. As you can see from the map here today, our speakers will be featured really from around the state. And you can see that they're all located along our major interstate corridor. So today's panel will feature speakers engaged in advanced energy research that applies to both lunar, planetary, and deep space missions. I'd like to go through each of our speakers and introduce them. We will have Dr. John Sarrao from Los Alamos National Laboratory. He's the Deputy Director of Science, Technology, and Engineering. We'll then hear from Geoff from Sandia National Laboratory. He's a manager of advanced nuclear fuel cycle technologies. We'll have Spaceport America and acting CEO and Director of Business Development, Scott McLaughlin. We'll then hear from Commander Eric Felt, who is representing the Air Force Research Laboratory and Kirtland Air Force Base. And finally, last but not least, we'll have New Mexico State University with Director of the Physical Science Laboratory, Eric Sanchez, as well as Dr. Steven Stojak, physicist with the School of Electrical and Computer Engineering. So before I hand it off to our first speaker, I just want to remind you all to participate in our post-session survey, which will show up after this session. Also, we encourage you to ask questions throughout the session. Please put them in the chat box, and Dina and I will get to them following our speakers. So without further ado, it's my pleasure to introduce our first speaker, Dr. John Sarrao.
Great. Thanks, Dina. Thanks, Myrriah, both for the introduction, but also for the context for the session. And thanks to all of you for joining us today. It's an honor to participate in the Canadian Science Policy Conference. Looking forward to a robust conversation. As Myrriah said, my name is John Sarrao. I'm the Deputy Director for Science, Technology, and Engineering at Los Alamos. And what I want to do in the next few minutes is share our perspectives on energy research opportunities and space research opportunities. And to sort of foreshadow my conclusion, what I'll try to convince you of is a pretty exciting time and an exciting future, especially working to grow partnerships with both our Canadian colleagues and all of our friends in New Mexico, represented by the institutions they come from. Now, if I were to ask you to describe Los Alamos in one word, almost for sure, all of you would say nuclear. And I think that's reasonable, given our Manhattan Project history. But as the slide is showing here, we have a history in space that's almost as old as our overall history. So we've been very active in space since the early 60s, working on challenges from national security questions like non-proliferation to nuclear energy and a variety of different technologies, all the way to sort of very fundamental and foundational science. So one of the takeaways I'd like you to take away from today is when you think Los Alamos, don't just think nuclear, also think space. That tradition of activity in energy, especially nuclear and space, continues today. And the way we think about it is that the enabling science, technology, and engineering that we do underpins both our national security mission, which is very important to us and very much goes to sort of our existence as a national laboratory, but also very much influences our activities in science and space exploration. So from the most open things we do to the things that we relatively keep to ourselves. I think one of the important messages, I think for all of our institutions, but especially for us at Los Alamos, is even though we do have a national security mission for the United States, we are very much open to collaboration and partnership across almost everything we do. And that certainly includes our colleagues in Canada. And that's why a big part of why I'm excited to be part of today's discussion. So to convince you that we really are active and busy, let me show you here. This is just a snapshot of the things we have going on in space in the next year, very much in partnership with our colleagues at Sandia, our colleagues at Spaceport in America, colleagues across all of the state. So what you can see on the left side of the slide is a set of missions and activities we have involving national security. And one of the key takeaways I think here is, yes, we do build very large satellites, we field instruments on them, and that continues to be an important part of our scope. But it's also the case that things like CubeSats have come to national security space as well. And so in addition to that sort of technology change, I think it also foreshadows a change in the role of the commercial sector in that space. So big activity in national security, big technology changes, big opportunities to partner. We're also very much excited and interested in the work we're doing in science and exploration. We have a significant role in the Mars rover Perseverance. Just a few weeks ago, it made its way halfway between here and Mars. And so we're looking for hopefully a not exciting day in early February where Perseverance touches down safely and begins a great science campaign, building on the success we're already having with our Mars Curiosity rover. But that's not the only work we do. There's a variety of other activities as well. In addition to all the excitement that's going on relative to space, there's also a large activity. My slides seem to be stuck, but I'll just keep talking. What I wanted to foreshadow is that in addition to all the activity going on in space, there's also quite a lot of activity in nuclear energy as well. So, the theme of this session is advanced energy research in general. Certainly, we, Los Alamos, are very active in that space, but we also have a particular footprint in nuclear energy, and that's what's shown in this slide. And, I think a strength of our own effort is to span a variety of scales and a variety of technology maturity from very foundational modeling and materials research all the way through to demonstration. And so that both motivates our activities, but I think it also creates an opportunity for partnering. So we're very active across the full domain of nuclear energy with a diversity of platforms and, again, a diversity of partners. And so then finally, on the last slide, what I wanted to highlight in particular was the particular opportunity that microreactors provide. And as the sort of the relatively busy slide depicts, here's sort of a history of snapshots of Los Alamos' history in nuclear. And I think why microreactors is a key part of the future is, firstly, as we think about doing just on the energy side, reactors at a variety of scales, from very large to very small, it opens up the opportunity space for more people to be involved. There's also an obvious resonance between smaller scale microreactors and using them as energy sources for a variety of space missions. Today, we use plutonium heat sources for a variety of energy sources, but as we deploy more energy availability to space missions, there's more and more work we can take on. A key part of that is doing it safely. Part of what you're seeing is a demonstration on the right part of the slide of an experiment we did called Krusty. that we did together with some of our both partners in Department of Energy and also the U.S. Space Administration, because safety and security really are key to successful use of applied energy sources in space. And so with that, I'll stop. I'll turn it over next to my colleague Geoff Fries from Sandia, who's going to talk in particular about certain aspects of nuclear safety and security. So Geoff, go ahead and take it away.
Great, thank you, John, and that was a great lead-in. I am Geoff Fries with Sandia National Laboratories, down the road from Los Alamos, also in New Mexico. Although I should point out, while I am at Sandia, I have a lot of Canadian blood. I grew up in Vancouver. I have a degree from University of British Columbia, and despite having been out of Canada for 30 years, I somehow still have an allegiance to the Vancouver Canucks, however futile they often are. Anyway, I'm going to talk about a specific aspect of space missions, which is space launch safety. So this slide just shows a history of space missions that indicates we've actually had nuclear space missions since 1961, which is not that different from the, I don't see my slides, so I'll work from my hard copy, but not that different from the timing of the implementation of nuclear power itself. Like John said, and similar to Los Alamos, we have experience not just with the nuclear space missions, but also with nuclear energy and nuclear waste safety. It all sort of works together. At the bottom of the screen, you see highlighted the Mars Science Laboratory mission, the Curiosity rover, and then the Mars 2020 mission with the Perseverance rover, and I'll talk a little bit more about those missions. So, as I mentioned, Sandia supported space launch safety for missions with nuclear payloads for a number of years. That includes missions with thermal heaters, radioisotope heater units, or RUs, and also radioisotope thermal electric generators, or RTGs. Going forward, there's also now a push for nuclear thermal propulsion, so actual SMRs or micro reactors that will be powering the spaceships. And all of those missions are going to require launch safety analysis specific to nuclear issues. We produced what's called the final safety analysis reports for the MSL mission in 2011, and more recently the Mars 2020 mission, which launched just a few months ago and is nearing Mars, as John mentioned. So in addition to space launch safety, a couple of other areas where Sandia has a history or expertise. Nuclear propulsion that I just mentioned, we do have some R&D efforts on SMRs and micro reactors, and on some of those we do collaborate with Los Alamos and some of the other national labs. So that'll be relevant to the nuclear powered rockets that are under investigation going forward. Also, space power systems. Some older work on the development, or at least the planning, of a nuclear-powered moon base, and also solar electric propulsion systems for near-Earth or in-orbit operations. And these can leverage R&D at Sandia on electrical microgrids and also in photovoltaics and concentrating solar thermal power. So a little bit of more detail on what space launch safety actually involves. So on the right, you'll see a number of pictures of various accidents. About 1% of all launches fail near the pad. So the safety analysis is required to look at potential hazards from accident scenarios. This is a detailed modeling exercise that all gets documented in what's called the Final Safety Analysis Report, or FSAR. It identifies various accident scenarios during pre-launch, launch, and re-entry, and looks at the potential radiological risk. So when I'm talking about a safety analysis, this is specific just to the risks from nuclear, from the nuclear materials. And this can enable the mission designers to make changes or make improvements if necessary to make sure that it's going to be safe from a nuclear standpoint. This involves work with a lot of different agencies, DOE, NASA, and various national labs. So I mentioned the detailed modeling. So there's a number of phenomena that get investigated that could happen during a typical launch. There's a graphic in the bottom right showing sort of the sequence of a launch. You may have blasts, fires, impacts, issues on re-entry. From all of those, you'd be calculating the atmospheric transport of radionuclides and then the potential consequences. All of this is put together in a probabilistic estimate of the radiological risk and documented in the Final Safety Analysis Report. And so regardless of the nuclear mission, this sort of safety analysis is going to be required. And so this modeling of the various phenomena is something that Sandia has a lot of experience and expertise in, again, for space missions, but also for reactors, nuclear waste, and other nuclear incidents. So in summary, at Sandia, we have the capability to support these space missions and interface with other labs and industry partners, and we'll continue to perform safety analyses as required, produce final safety analysis reports as required by, previously it was the Presidential Directive NSC 25, and going forward there's a new National Security Presidential Memo that's going to govern how we document and ensure safety of nuclear missions. So thank you. And I guess the next speaker.
That'll be me. All right, I'm Eric.
Oh, go ahead.
I'm Eric Santos. I'm the director of the Physical Science Laboratory here at New Mexico State. Career Army Air Defense officer with 32 years on active duty, with my last duty assignment as the commanding general of White Sands Missile Range. Steve.
And I'm Steve Stoy. I'm a professor in electrical and computer engineering. So I thought we'd like to start off with just giving a little bit of the deep history in space that New Mexico has. So Robert Goddard, who's considered the father of modern rocketry, was kicked out of Massachusetts because they didn't like him doing rockets in his backyard, and came to New Mexico in 1930 to pursue his rocket testing. And he is famous for having the first liquid fuel rocket. He also has patents for multi-stage rockets and clustered engines. After World War II, a lot of the V-2 rockets from Germany were brought over to White Sands, which is very close to us in Las Cruces, New Mexico. And PSL was started to help analyze the data taken with those rockets. And we're also very lucky to have two faculty members, Rita Beebe and Bill Weber, who were original project scientists on the Voyager 1 and Voyager 2 missions.
So I want to quickly go over PSL and what our current capabilities are. We have 3 divisions made up of aerospace, telemetry, and missile systems. and Information Sciences and Security Services. I'll focus on the first two, aerospace and telemetry and missile systems, as those are the most relevant to this panel. So in aerospace, we do a couple of things. We work closely in the UAS test realm, and we're one of 7 FAA approved test sites around the country. We do above 60,000 feet solar powered aircraft, just to name one example of what we do. We do all kinds of different testing from very low to very high in that regard, and we work closely with Spaceport America on some of the altitudes that are beyond our capability. In telemetry and missile systems, this goes back to the history that Steve talked about. We stood up this organization in 1946, focused mainly on telemetry systems, as he discussed earlier. We have a product catalog that we produce here, design and produce, and a number of partners that we work with, as you can see there on the slide, is NASA, the Navy, and the Missile Defense Agency. We have a number of different programs that we support in that regard. And then quickly on information and security services, that's mostly focused supporting the Army on vulnerability and survivability of different weapon systems. And then finally, production capability, which is tied mainly to the telemetry and missile system division, but we also have the ability to support a lot of different activities as well. I want to spend more time on the high altitude balloons, because that's one of our focus areas. We have a lot of expertise in high altitude balloons. As a matter of fact, we are currently in the middle of a proposal to win back a contract that we had lost 5 years ago after 25 years supporting the NASA balloon program. So that's ongoing right now. We have a suspense date of the 17th of December, so a lot of work going on in that regard. But as you can see on the slide, what we do in regards to high altitude balloons, in addition to NASA, we have a couple of other programs that we support. The Swedish Space Corporation, we support them. We've built flight hardware and software to support their mission control, as well as small balloon support in testing of telecommunications, and also supporting a lot of high altitude airship development efforts as well. Steve, I'll turn it over to you.
And Eric is interested in the operation of the NASA balloon program, and I'm a user of the NASA balloon program. So here you see a launch of a scientific balloon to study cosmic rays. And the interesting part about this is this launch was done from beautiful Lynn Lake, Manitoba. So it's kind of nice for me to spend summers up where it's cooler. The next picture over is an international program that I'm involved with called Pomella. This was an Italian-led effort that used technologies developed on the balloon platform to make a space-based version of it. And this satellite operated from 2006 to 2016 and had researchers from Germany, Sweden, and Russia, in addition to Italy. And last, there is a picture of a CubeSat in our clean room that's awaiting launch right now. And this is a space weather mission. It's interesting because the big tall guy in the back, Mark Roberts, just completed his master's on the analysis of in situ proton and electron measurements made on the GPS constellation with instruments provided by Los Alamos National Laboratories. So there's another connection there. Right now, we are working on 2 other spacecraft. One is called SASSAT, and this is 2 satellites that are going to perform proximity operations, alignment, and also docking. And this is an interesting project for us because it has an industry sponsorship, and that's Northrop Grumman. Carrying along in those lines of spacecraft operating in orbit in a cooperative fashion, we have the Virtual Telescope for X-ray Observations, VTXO, and this is a new way of imaging X-rays. So it uses something called the phase Fresnel lens, which changes the phase of X-rays to produce an image. This is a very promising technique. The only drawback of it is it requires very long focal lengths. In the energy range we're looking at, the focal lengths for about 1 kilometer, so it forces the lens to be on one satellite and the camera to be on the other satellite. And that is a joint project with the Space Dynamics Lab and Goddard Space Flight Center in Washington. And that ends our presentation. Back to the moderators. Oh, sorry.
Good, I think I'm on. So, hello everyone. Thanks for having New Mexico be part of your conference. This is very exciting. I'm going to talk about Spaceport America briefly. And as you can see from the slide, one of our bylines is the world's first purpose-built commercial spaceport. And there's a lot packed in there, but a commercial spaceport is something that's relatively new in the world. All the spaceports before have been run by the government. They've either been military or they've been run by NASA. A law in the late 90s allowed in the United States that commercial entities could launch rockets and that they could even run a spaceport. And of course, we just saw last week, or we saw SpaceX operate as a taxi for NASA. Very, very, very exciting. I mean, it's exciting for the United States to be able to not have to pay the Russians anymore, but it's exciting for the whole space community that technology has gotten to the point where NASA can basically stick out their thumb and get a ride to the space station. And I don't know anybody who thought that would happen as quickly as it actually did. So Spaceport America is a commercial spaceport. We're not quite ready to go to orbit yet. We think that's probably in our future. But you can see on the first slide there are a couple of activities. I'm going to show you some more. But the one on the left is a solid rocket being taking off on a rail. And just below that is what it did up in space on the suborbital flight above the Kármán line. This was a NASA payloads opportunity project, and that we've had quite a few of those. This company, Up Aerospace, which is out of Denver, has launched, I think they're on their 14th flight from Spaceport America since 2006. Right next to that is the Virgin Galactic. I'll talk about them a little bit later. And then to the far right is Exos Aerospace, which is a liquid rocket that's has some very unique attributes. It's also designed to go to space on a suborbital flight, but it's liquid. It takes off slow, so it has a guidance system, and it even has a parachute system that can bring it back to the spaceport. So let me go to the next slide. Now you can see a picture of the spaceport, and it's about 18,000 acres or 73 square kilometers. It's about 10 miles top to bottom. We have 3 separate areas buried in there. One is the horizontal launch area. That's at the very top. That's where we have a 12,000 foot runway. It's a very wide runway, 12,000 by 200 feet. In the middle there, we have the vertical launch area, and that's where the vertical systems take off. And at the very bottom, we have an area called the advanced technology area. And what we try and do now with the space is separate our customers and control our airspace. Our airspace actually comes from White Sands Missile Range. And as Eric talked about, we partnered with Physical Science Laboratory on some of our most recent customers, and I'll show you a picture of that in a minute. Part of what makes us unique, though, is the airspace from White Sands Missile Range. So White Sands Missile Range started out in the mid 40s. It was the site of Trinity site, the first atomic explosion, and of course the V2 rockets that showed up on Operation Paperclip when the German scientists decided they'd rather come to America than USSR, and we're happy they came. So anyway, so the White Sands Proving Ground at the time turned into White Sands Missile Range. And part of the Commercial Space Act of the late 90s was that the DoD must share airspace, share facilities, and facilitate commercial launch. And that's why Spaceport America was located where it is. So you can't tell from this little slide, but we're in the high desert basin, like a lot of New Mexico. It's wide open spaces. There are very few people who live in the area, so it's a very, very good place to put a spaceport. What else have I got there? The weather is great, as many of you already know. We don't have any salt air, so things don't tend to corrode out in the space. And we're already almost a mile up. So for our suborbital customers, they get that first mile for free, basically. Moving on to the next slide, I'll show you some quick activities. So these are some of the things we've been doing for the last several years with Spaceport America. The very top is one of our companies, Up Aerospace, manufactures their own engines on site. They also test them sometimes. So they manufacture them, they test them, and they launch from Spaceport America. We've also had, now we're about to have a second company come in to do liquid engine testing, and they're from Canada. It's C6 Launch, and we're very excited to have them come. Of course, we have the CST-100 has launched on parachute out of Spaceport America to test its, launched on balloon to test its parachute system. And then you can see some pictures of some very large UAS systems that Eric spoke about. Those are solar powered systems. The big one on the far right is 262-foot wingspan, so almost as much as a football field, and can fly up to 80,000 feet. And it's designed to stay up 6 months at a time. The one below it is much smaller, but it has the same kind of ConOps, a concept of operation that's designed to be up in high altitude, stay for a long period of time. So part of what I wanted to demonstrate this slide is just a large number of things we can do out at Spaceport America. You can think of us as a test range. We have the capability to do a lot of things, and in fact, on Monday it was announced that Stratodynamics, another Canadian company, was coming out to test their high altitude system, which will also use a very unique technology called infrasound, which oddly also connects to Los Alamos. Infrasound has been used for years to detect nuclear explosions. It can also hear tornadoes and elephant stampedes. So the idea that it can actually hear high altitude turbulence is very unique, very interesting. And I have a background in atmospherics, and I'm very excited to have them there. Real quick, here's what we were hoping would launch today, as a matter of fact. In fact, I almost had to call Myrriah and tell her I wouldn't make it. But unfortunately, because of COVID, the mission that Virgin Galactic was planning has gotten moved off. We hope it will happen in December. When it does happen, and it will be only the third state to host humans going to space. So this kind of goes back to that theme that New Mexico has been doing this a while. And here we are breaking some new ground. So it's hard to even say how excited we are, because the spaceport was paid for by the taxpayers of New Mexico. So to finally see this investment turn into the original intent, besides all the other things I talked about, is very exciting. One last slide is we're now home to Spin Launch, which is located in the southern part of the range. This is going to be at our site, will be a 30-meter evacuated centrifuge, and it's literally going to throw a first stage up to the Kármán line, and it will land in White Sands Missile Range. Their goal is to expand this to 100-meter size sometime in the future, and it will actually act as a launch system, and they intend to install a few of these around the world. We hope to see them operating sometime in early spring. So just a smattering of what we do at Spaceport America, and that's all I've got. Thank you very much for your time.
Good afternoon. I'm Colonel Eric Felt. I'm thrilled to be here with you today from the Air Force Research Lab Space Vehicles Directorate in Albuquerque, New Mexico. And what I wanted to share with you today was some of our research that's going on in space. It's certainly an exciting time to be working in space, probably the most exciting time since Neil Armstrong set foot on the moon in the 1960s. Because there's so much going on, but there are some differences between this space renaissance and the first space race that we had in the 60s. And some of them are highlighted here on this slide. The ones I wanted to draw to your attention were, first of all, that race was a race in the Cold War between two nation states, the USSR and the United States, racing to the moon and for space dominance. This race is not being driven by governments. It's really being driven by the commercial sector. National interests still play a role, but the commercial sector is really in charge of driving this second space age. Some of the examples of the constellations that are being put up are shown there between Amazon, SpaceX, OneWeb. It's just incredible, the thousands of satellites that are envisioned being added to orbit in the next 10 years or so. And not just the traditional orbits, the low Earth, medium Earth, and geosynchronous orbit, but we're now looking all the way out to the moon and beyond in terms of areas of operations for our United States Space Force, and because all these commercial companies will also be operating out in those regions. So on the little box there, I highlight just a few of the differences that we see between 1969 today and 2030. But in terms of the number of objects, just incredible, the growth that we're going to be seeing there. And we're going to need to be tracking, shoebox size, autonomous objects that might be all the way out to the moon. And that's a real challenge from a space domain awareness perspective. Many different orbits involved beyond just the traditional geo orbits that we've talked about, and many different players involved. Now we've got already up from 7 nations in space to 12, but a whole bunch of commercial activity going on as well. So it is a super exciting time, and there's some important differences between what we are seeing today versus the first space race that we had. So at Air Force Research Lab, our mission is innovation, and we're here to do science and technology innovation on space vehicles. And we've separated ourselves out into 7 different mission areas so that we can do appropriate horizon scanning within each of these areas to keep aware of the technologies that are going on and the innovation that's happening, not just in New Mexico and the US, but certainly in all of our allied countries and around the world as well. So just as one example, I'll talk a little bit about position, navigation, and timing. So certainly GPS is the world standard in how we accomplish this, but we've got some threats to GPS in that it is a signal that's very easily jammed. And if we were ever in a wartime environment, we are very concerned that the GPS signal would be jammed. In fact, the GPS signals are jammed every day. So a lot of our research is trying to figure out, okay, how do we overcome that with different new technologies such as software-defined radios and phased array antennas. And the picture shown there is Navigation Technology Satellite 3, which is a satellite we're going to be launching in 2 years to attempt to get after some of those challenges with modern technology. Missile warning and intelligence, surveillance, and reconnaissance, of course, is the bread and butter of missions that we've done from space for a long time, but there's still lots of new technologies available there to help us get after increased persistence and new phenomenologies and things like that. Understanding the space environment is super important to us, and because we want to be able to use that environment and understand that environment so that we know if, for example, if our SATCOM signal is not going through, whether that's due to a solar flare or whether that's due to adversary activity. And that's a really important information for us to have. Pervasive technologies is the area that we refer to for how we make small satellites act like big satellites. And so each piece of the satellite is important to do research and make advancements in. Satellite communications is our main lines of effort there are to get after the research against jamming. Space control, our main effort there is space domain awareness, making sure that we know everything that's going on up there and that we can protect and defend our space capabilities. And then within the Directorate, I also have nuclear deterrent operations, which is a slightly different mission area, but is becoming super important as the United States recapitalizes the nuclear triad. So that's how we've organized ourselves and some of the research that we conduct. I just wanted to share a few examples with you here. In the space domain awareness area, some of the challenges that we face as we go all the way from very low Earth orbit, where you have to be constantly thrusting to avoid re-entering the atmosphere. Down there, it's difficult to predict the orbits. Up in the low Earth orbits, we've now got thousands of satellites. It's very congested. Up in the MEO and GEO orbits, we've got a harsh radiation environment we deal with, and we're trying to, again, keep track of all the assets that are up there. And now there's the region above GEO, which we call XGEO, where it's a vast region, 1,000 times the volume that needs to be searched as we go out to the moon and encompass all of that area. So those are some of the challenges that we're facing. certainly cannot do it alone, and we're very interested in partnerships with allied nations, partnerships with commercial entities, whether in the U.S. or friendly foreign commercial entities also. One example of those partnerships is what I call the Microsat Military Utilities Study, or demonstration that we did. And this was really just a test. We said, hey, there's so much commercial activity now, so many intelligence, surveillance, and reconnaissance satellites going up there for commercial purposes. If you just bought up all that imagery and pieced it all together, could you get enough persistence over a battlefield of interest that it would provide some military utility for our commanders? And we did a test of that in RIMPAC 2018. The countries involved are shown there on the bottom. It was a 9-nation project agreement, and it was super successful. We basically bought up all the imagery from about 250 satellites that were up there at the time, and we pieced all that together so that the commander in the battlefield could maintain awareness of what was going on up there, and it turned out to be super successful. There's still some gaps, but it had a much higher degree of persistence than we were ever able to obtain from our U.S. government systems by themselves. So that the key takeaway from that, though, was that it's super useful, but we've got challenges in the timing of it. We need to streamline and standardize the tasking, and then also the delivery of the images afterwards. So that's now our current focus of research in this particular area. Lastly, I'll leave you with what my prioritized initiatives are, and really we've just completed a strategic planning process where we went through, okay, what are all of the needs that we have in space? What are all the current science and technology projects that are underway in space? And then what are the gaps? And then we attempted to prioritize those gaps based on how important we think we are to the future warfighter. And so this is the list that we came up with, and I offer this to you as a starting point for discussion and collaboration as we move forward. If you are interested in these topics, maybe we can do a project together. Again, thanks for the opportunity to being here with you today.
Fantastic. Thank you so much for these exciting presentations and really just deep diving into the daily space work that you do. As you know, the Canadian government in 2019 has announced a number of investments in the space sector. We've announced $1.9 billion over 24 years for the next generation of smart AI-powered space robotics for the NASA-led Lunar Gateway program, $150 million over 5 years in support of our new Lunar Exploration Accelerator program, which will help small and medium-sized businesses in Canada develop new technologies to use and test in lunar orbit and on the moon's surface in fields that include AI, robotics, and health. And thirdly, we're certainly investing in satellite communications with $85 million put into Canadian company Telesat to build and test innovative technologies for low Earth orbit satellite constellations. So you've got on the line today our entire Canadian research and innovation ecosystem, and they're certainly most eager to collaborate with each of your institutions. Can you give an example of how you've worked with foreign research institutions, small, medium-sized businesses, and brought in foreign students within your respective organizations? And I will start with John from Los Alamos Labs.
Great, thanks, Dina, and great question. So, as you say, non-U.S. citizens play a very important role at Los Alamos. That's been true since the Manhattan Project. Many of the greatest innovations we did were not actually made by U.S. citizens. That continues today. My boss, our lab director, is actually of Canadian descent, so he has a huge soft spot in his heart for Canada still. All of his extended family still lives in Canada. And when Dina and her colleagues last visited Los Alamos, I think we had something between 50 and 100 Canadians on the payroll. So to get to the question, I think there's at least 3 channels. One, come work for us. We're actively hiring. As I said, there's a number of Canadians who are in our active employment today, and especially for our student populations and our postdoc populations, which are a huge part of our workforce, we're very often plurality, if not majority, non-US citizens. So that's a direct connectivity working for us directly. In addition, secondly, I think there's a variety of research collaborations we have between us and various university partners, in a whole variety of fields, all the areas that Dina highlighted and many others as well. A really easy entry point is one of the things that we Los Alamos have, as do many of the national laboratories, including Sandia as well, are national user facilities. So CENT, our Center for Integrated Nanotechnologies, is actually jointly stewarded by Sandia and Los Alamos. We welcome users from around the world all the time, just by very simple research proposals, that we give you the resources just if you're willing to be non-proprietary in the results. We have a variety of other user facilities as well. And then thirdly, our actual business arrangements, CRADAs, MOUs, all kinds of those transactions. We're very open to that. I'll be honest and say it's also the case that those agreements can be bureaucratically complicated and take longer than they should. Frankly, that has nothing to do with the fact that it's a US-Canadian agreement. Even our US agreements can take a while. And so I guess my suggestion would be twofold. One, figure out the technical scope you want to do, meet a technical PI first, because once we figure out the technical scope, we can make the bureaucracy work. And then also, huge shout out to folks like Dina and folks like Myrriah and their offices, because they can be conduits to sort of working through that bureaucracy and creating three-way arrangements. We can partner with the universities in New Mexico and all of you to bring us together in a broader consortium, and that can often be easier and faster than just the direct agreement. So I'll leave it at that, Dina, and hand it back over to you.
Fantastic. Let's pass the mic around to our other speakers in order of presentations. So Geoff, over to you.
Okay, thanks, Dina. And so the story at Sandia is a little bit similar to what John described at Los Alamos, given that we're both national labs. Again, we of course have also lots of non-US researchers that are employed at Sandia. We also have a number of relationships with foreign organizations, companies, specifically related to the nuclear industry. My day-to-day job is nuclear safety, whether it's space missions, nuclear energy, or nuclear waste. Just the other day, I had a telecon in the morning with Israelis, a telecon in the evening with Australians. No Canadians that day, unfortunately. But as an example, we were approached recently by a Canadian company who was interested. They're in the area of advanced nuclear reactors, and they were interested in getting some support on nuclear waste ideas. They approached us. We've since signed a non-disclosure agreement with them, so we'll be going forward. We'll be working together with them to help them solve their problems. So, yeah, if you're interested, approach a PI like John said, or again, go through Dina or Myrriah or other avenues. We're always happy to support interesting technical endeavors. Thank you.
Eric?
All right. The majority of our work that we do with other countries are tied mainly to the UAS program that we have, scientific ballooning, and a little bit with telemetry and missile systems. We do have a flyaway capability that we send to different countries. Some of the countries that we've dealt with in the last few years, I would say, is Sweden. We do a lot of work in Antarctica. We've worked with the Israelis, New Zealand, and Australia. So, and as far as working with students, not too much here at PSL because we are a classified facility, and a lot of the work that we do is classified. But I know Steve on the other side of the road here on New Mexico State University has a lot more that he does with those students. I'll turn it over to him so he can explain more.
So a lot of the research opportunities have been between university to university, and we've had A number of foreign graduate students spend semesters at NMSU or years at semester working on projects. It's interesting because AF4L has a great program called the Hyperspace Challenge. And for some reason, Colonel Felt allowed universities to participate for the first time this year. And we have made several contacts with small space startups. And I think there's going to be some real partnerships formed from that. So I'd like to thank again Colonel Felt for giving us that opportunity. It's been a very rewarding experience for us.
Fantastic. Scott?
Sure. Yeah, we're open as a test range in our airspace. We're basically open to anybody around the world. You know, it's we've been talking to several of the entrepreneurial firms in the world that might want to come here either to fly into space or to fly or to launch a rocket to test. We're a really good place for like a suborbital test of an engine or a first or second stage where it's never flown before. So working with us is pretty easy. We're a state agency, so it's not quite as difficult as trying to get on, say, the White Sands Missile Range or a federal range. So we try and make it easy. And we also, I should also mention, we do the Spaceport America Cup, which is an intercollegiate college competition of aerospace. And I think we've got a couple of Canadian teams last year. Unfortunately, we had to cancel it this year, but we had a total of, I think, 14 different countries from around the world come and fly with us last summer. So watch for that. And if you're in college and you're in aerospace or somehow connected to a program, you know, you can come out to Spaceport America and fly.
Fantastic. And Colonel Felt, I was so happy to see the Canadian flag on your microsatellite military utility collaboration project. Hoping for more.
Exactly. Well, I have three things to say really about international partnerships. The first is that these international partnerships and relationships are very important to our Chief of Space Operations, General Raymond. He talks about them regularly as one of the things that makes our nation and our free world strong. And so he wants us to pursue those. And so it's a very important emphasis item to him. That's why we why we have a long history of NORAD, and in the space domain, we have a long history of combined space operation with our allies. So those are very important to, you know, my leadership and my customer. And so oftentimes it's easy for us to do partnerships in the science and technology area, and we have a number of them. I highlighted one of them already, this MSMU study is a great example. And as we have small satellites, it's way easier to collaborate with other nations with small satellites and following common standards than it is necessarily to build a big, exquisite satellite. So lots of opportunities there. I really appreciate the call out on the Hyperspace Challenge and how we did bring in universities this year. That's been a super great source of innovation for us. And the other thing the third thing I wanted to mention is just the International Space Pitch Day. That is an event that I was one of the judges at that on Monday of this week. It was in the UK, you know, nominally, but it was a virtual event. We had small companies pitch us from India, Australia, Canada, the UK, and the US. And really, I think that laid a great foundational framework for a lot of potential future collaborations, you know, direct from our governments to industry partners in these various different nations. And we also work closely with NASA on the Artemis Accords, which are their standards that they are you know, putting in place with our partners and allies around the world for returning to the moon and getting after norms of behavior in space. So those are very important to us as well. So I think there's lots of opportunities, and look forward to always putting new ones in place.
Yes, and for those of you on the line, we're working really hard to get Colonel Felt to participate in a Canadian startup competition in our own neck of the woods. So more to come on that front. And as well, just to conclude this question, Canada launched over a year ago a Canadian international education strategy. We are certainly welcoming international students and researchers to come to Canada to pursue research opportunities. So, you know, it goes both ways. You know, we certainly would welcome talent in your own institutions to go up to Canada for that cross-border pollination of ideas. So passing it over to Myrriah for the next question.
Thanks, Dina. I have, before I get to the moderated questions, I have one question for Scott. I was wondering if you could talk a little bit about spin launch, companies like spin launch, and those that are interested in being recruited to New Mexico, and talking a little bit about the spaceport related activities and incentives that can be used by these companies.
Yeah, so Spin Launch is an example of a company that could have come out of something that Eric is talking about, the general talking about in terms of an entrepreneurial company. They're actually venture funded. They come from the Silicon Valley area, and the principal of that company is not an aerospace engineer. He doesn't have an aerospace background. What he had was an idea. And you know, one of the things that we need to do better of in New Mexico and is teach people that an idea can be turned into a business. You know, you just don't have to go work for somebody else. You can go work for yourself. And that's a huge empowering thing that people don't really think about sometimes as they go through school and they go through college. And New Mexico is definitely trying to set themselves up better. We do have incentives. Spin Launch has gotten incentives for this. I wish I could show you a picture of the site, which is probably 46, somewhere around 50, 60% done. But it's an incredible site, and they've gotten incentives that have helped them get some workforce. They'll also get some incentives later on that are going to, assuming they hire the 30 to 40 people we expect them to hire to be on site to run this centrifuge, they will get some help. And so New Mexico has been pushing hard on a lot of fronts, especially in the technology and aerospace side, to help those companies that want to grow, that they can come to New Mexico, and it's a good place to start their company and a good place to grow. So Spin Launch is probably a great example, so thanks.
Thanks, Scott. And then, so we have a question from the audience. With there being so many CubeSats and other satellites going up into the suborbital space, what are you doing about space traffic and junk? That's the question.
I guess I could take that one because it's a big concern for us. And I did highlight how we've got, 1,000 times the number of satellites going to be up in space soon. And we really do need to do space traffic management and establish some standards and some transponders and some norms of behavior. And so what I'm trying to work on in the research lab is the key technology enablers to enable better space traffic management. And so if you look at the air domain, where every airplane has a transponder that can be queried by other airplanes, that's kind of the model that we want in space too. I think that's achievable, even if it isn't a direct satellite to satellite link, but rather a link through a virtual cloud ground station is kind of what we have in mind. But there's lots of need for work in that area, and also in debris mitigation, which turns out to be a very challenging problem. But as soon as we have a couple of collisions in space, we're going to have a big debris problem. And so I think that's also a very important area for research that we are pursuing and looking for partners.
Fantastic. And just to continue on that question, how do you feed into advising your own government in terms of the regulatory framework for space activities?
I guess I can take that one. In fact, on the commercial side, AST, the Office of Commercial Space Transportation, which is part of FAA, just released a new rule. It's called Part 450. And that rule has to do with launch operators. And that was supposed to be a big update to the safety regime for launch operators. There's also one for launch, and there's also one for reentry. They say they're going to examine those and update those in the next year. Those will affect Spaceport America directly as a spaceport. But it's taken a little while for the FAA to kind of get in gear in terms of being responsive to the commercial market. Like General Felt talked about, if you go back in time, just a few decades, this was all a federal thing. There wasn't a commercial thing. rocket was paid for and developed by the government. And if you want to be an entrepreneur in the space sector, you needed to develop a flight computer or a new material or a fuel tank or something. As we now know, it's the billionaire field out there, but there's many others who are developing their own rockets, and that is what is driving the industry. We're growing. The commercial space market is growing at a very high rate, and it is a great time to be in space. And that is starting to inform the government more and more on how to be responsive in the regulations. So one quick example is, rather than telling a contractor how to build a capsule door, they, specifically, it's more about the requirements for the ability to open and close and get out of the door. It's a performance-based instead of prescriptive. And so our government has been responsive. I think the part of the keys of the United States is the ability to invest and get money, and the government has reacted toward the commercial space market. So it's been an important partnership.
Fantastic, thank you for that. Another question coming in from the audience. So what are the action items Canada and US partners should focus on for their next steps in space exploration?
So maybe I'll chime in on that one a little bit. I think both Scott talked about the commercialization of space and both the opportunity. You highlighted there's the regulatory challenge. I think for us the most important thing is finding those technologies that create opportunity. So we talked about sort of the space management thing. We're focused on on creating sort of basically license plates for satellites so we can track them. It's those small scale innovations, partner to partner, that really are the big breakthroughs. I wouldn't want to make a particular list, because I'm sure the folks out there have much better ideas that I could come up with. So if you've got anything to make an impact, just reach out, and we're happy to start a partnership.
So I would offer that good ideas have no national boundaries, and really it does boil down to what are the key technologies that are going to be able to provide transformational capabilities for us to know what's going on in space and to better explore space and to deter any war from happening in space. Those are the kind of things that we are on our mind every day. And so it boils down to what are the technical ideas, and when you have those, then you have a specific thing you can talk about. So I gave you my list of 13, but those are kind of general areas also. And so really, as you get into specific pieces of technology, that's where we can have the best discussions. And I think there's lots of opportunities for international collaboration when the technology makes sense and when we all want it and can see its value. And
just to build on what you're saying, obviously Canada has a very large geography. 95% of our population lives within 1 hour of the US border. So we have a lot of, remoteness and land touching the Arctic. One area of potential joint work, since you also have Alaska, relates to remote health, remote medicine, mining, and transport these lessons learned from our Canadian geographic environment to the space sector. What are your thoughts on that?
So I'd be happy to jump in, Dina. Exactly to your point, one of the things that the U.S. Department of Energy has done just in the last week or two is stood up an Office of Arctic Energy exactly for that point. So we're trying to enhance our U.S. engagement in Alaska, but everything that works in Alaska works in Canada as well. I think one feature of that is moving beyond just space, how we think about distributed power, remote power. That's a place where small nuclear plays a role. Obviously, in the U.S., we've got a big interest in critical materials, and given Canada's mining capabilities, big partnerships there. And then a third one that's maybe counterintuitive that also fits in. Canada has a quite strong program in quantum computing, which is something the U.S. is very interested in. So, certainly this nexus of space and energy in today's focus is huge, but there are a whole bunch of other topics we'd love to collaborate and partner in.
The first thing I was going to say is that the people in Canada and Alaska are super lucky because they're the first ones that get to use the SpaceX internet connection on the beta test, because it happens to be at that latitude you get the best coverage. So there's a lot of advantages to being near the Arctic for some of these new space capabilities. And one of the researchers in my AFRL directorate was just appointed as the Arctic lead for all of AFRL. So not just for space, but across all the other directorates too. She is super excited about that, and she's going to be pulling together all the technology needs for the Arctic, since that's clearly an important emerging area for the whole Department of Defense also. So again, I agree. Alaska and Canada and the things that are going on up there open up a lot of nice opportunities for us on the science and technology area.
Dina, this is Geoff. Just to add, so Sandia actually has a remote laboratory presence up on the North Shore of Alaska, primarily focused on atmospheric sciences, remote sensing, things like that. But it's, it supports, could be adapted to support space, could be adapted to support energy issues. So again, it's an area that we're open for collaboration and interested in.
Great. Thank you so much, Geoff. We have another question from the audience. They said low Earth orbits are getting very crowded, especially with the thousands of satellite launches planned in the next few years for SpaceX LaunchLink constellation and a similar competing constellation by Amazon. Is there an international regulatory agency responsible for allocating and managing low Earth orbits in order to avoid collisions that would create space debris, endangering other satellites and the International Space Station?
No, but we need one. Now, quite seriously, I think there's a lot of opportunity there to figure out what is the smart thing to do. I think all of the commercial operators are incentivized to, have some standards and protocols that people are going to follow. Again, I already mentioned from my perspective, I'm trying to work on the enabling science and technology, such as the license plate idea that was already mentioned. I love that kind of stuff that is very simple things that once the standard is established, everyone will be able to follow that. I think what I see right now is people are just kind of claiming an altitude, this is my altitude and this is my altitude, and that might be okay for a little while, but we definitely do need some better norms and standards in that area. I think that's an opportunity for an AIAA or something like that to kind of pull together across the nations and commercial sectors to establish some recommendations. I'm happy to help from the government side, but it's not just a government thing that we can do all by ourselves.
Mm-hmm.
Thank you. One more question from the audience here. So, according to Wikipedia, the two Voyager space probes had plutonium-238 radioisotope thermoelectric generators, RTGs, that generated about 470 watts of power at the time of their launch in 1977. Have there been major improvements in RTGs since the Voyager era?
Geoff, you want to comment on that one, or should I take it?
I can start with it. The answer is yes. I mean, RTGs and space heaters, the RHUs, are continually being improved. They're still plutonium based, but they get smaller, more powerful with time. And as I think I mentioned in my talk, I think the future focus is now going to be more on nuclear thermal propulsion. So actual small reactors, microreactors powering the spacecraft, whereas, the RTGs were powering the rovers, small little, vehicles, or just heating, equipment so that it didn't get too cold so it could, take measurements. So So yeah, I guess that's probably a good place to stop right there.
Yeah, no, so I would agree. I mean, Los Alamos continues to be active in making RTG sources for a variety of folks. The technology is certainly better than it was on Voyager, but those are still in some sense incremental advances. So it definitely is time for a disruptive advance that, for example, moves us from heat sources to powered reactors and other things. So key part of our success, but certainly room for significant innovation going forward.
Great, thank you so much. We have another question from the audience that says, the Indian Space Research Organization has emerged as one of the recent leaders for space launches and exploration. Do any of your organizations currently work with the ISRO? And if so, and if not, how can you initiate that collaboration, I guess, between the two countries and institutions?
That's a good question. So Air Force Research Lab does not work with IRSO, but we do have some other partnerships with the government of India on space technology. And I guess I see that's where the best opportunities are going to be. There's 138 launch startups that we're tracking now. So, and we, of course, are legislated that we will buy any launches in the Space Force from U.S. sources. So I think the launch market's pretty saturated, and that's good. That's a good thing that's going to benefit all of us, because some of those will survive and really be able to provide some enduring, low-cost access to space for everybody. But I think the key areas for collaboration are probably on satellite technologies and processing algorithms and things like that, rather than launch, at least from a AFRL perspective.
So my next question is for the panelists as well as my co-moderator. So how have you supported the small, medium-sized businesses that are part of your ecosystem to export to other markets? What are those other international ties that really make you the main, like the must point of contact in terms of space research for our for the Canadians on the line and other international conference policy listeners?
I guess I would say the collaboration between the group that you have here on the panel, in one way or another, there's collaboration going on between all of our organizations. Between Steve and I'm on the applied research side, he's on the research side, and so there's collaboration there, but we're collaborating with all these other organizations as well. So I think there's definitely a lot of possibilities to bring everybody together to work together.
Yeah, I agree that through academia we can accomplish a lot, and sometimes it's easier to collaborate at that level on kind of with the basic research, and so there's great opportunities there. With the hyperspace challenge that we already mentioned, we've tried to open that up to academia and by the way, to international companies can participate in that as well. The International Space Pitch Day. The whole idea is to build this international partnerships, because that'll help us out innovate our competitors and get better technology. When we do coach and mentor these startups, we also steer them to the Import-Export Bank and other things that might help them become exporters of technology, and other countries have similar mechanisms to help their countries become exporters of technology. And I think those are really good tools to have in the toolbox for any kind of startup as they're trying to start exporting their stuff. There's been a lot of reform of ITAR in the US, for example, which was a really big barrier for a while. Now it's a medium-sized barrier, but still something that has to be worked through. But I think there's, again, lots of opportunities, and we're always looking for more.
And I guess I'd add one piece to that. I think one of the strengths of our partnership with Myrriah's organization, for example, is of course doing things directly together between us and local businesses, but also just the fact that we're enriching the New Mexico ecosystem, that there are more, interesting companies doing interesting things, bring smarter, more diverse people to the region. And that certainly includes international partners coming to the neighborhood. So some of the opportunities directly with us, but just, all of us working together, you've heard the connection to us and our ecosystem. The more different people that come to the area, that just makes New Mexico better off and our partnerships better off as well.
I think, Dina, as someone mentioned earlier, the Air Force Research Lab hosts the Hyperspace Challenge. And so that's been an opportunity to have, I think, businesses from around the world and even from Canada, see what the capabilities are here in New Mexico. In addition, I'll mention that we have a New Mexico Trade Alliance. So this is a partnership between the local, state, and federal government to help companies that are interested in coming to New Mexico. So in addition to all our panelists today, we also have resources that can reach out to these companies and connect them to the right individuals and collaborators.
Yes, and I appreciate all the points you raised, from a North American competitiveness and security perspective. I think certainly encouraging, further cross-border collaborations between New Mexico institutions and Canada make a lot of sense. We also, as a country, have 14 free trade agreements signed, covering about 1.5 billion consumers around the world. So, there's also great opportunity for American companies to set up in Canada and launch globally, just to maximize the competitiveness angle. And I do have a follow-up question as well, because you mentioned diversity, and New Mexico is quite diverse and welcomes diversity. We certainly, as a Canadian federal government and country, are really promoting inclusiveness in trade and research collaborations. So have you put in place special initiatives to try to foster more diversity within the space streams of your various institutions?
So I can start. So yeah, at Sandia, and I think at all the national labs, there's a strong incentives and programs on diversity and inclusion to promote that, with people, with companies, with countries. Sandia just got a national award for being one of the top diversity and inclusion organizations in the country. So, it's certainly pervasive at our lab, and I would imagine John can have a similar story to tell at Los Alamos as well.
Yeah, no, absolutely. So thanks, Geoff. So I think for one, to your overall point, Dina, one of the things our lab did over the last year was adopt a culture statement that is how we do our work is important as what we do. So that sets the context. I think part of what's exciting about space that you've heard throughout this whole panel is as the technology has gotten small, when you're doing, big launches that take decades, that's really exciting, but it takes time for things to evolve. When you're talking about, making a small CubeSat and launching that from Spaceport America into low Earth orbit, the burden of entry is lower. And so that creates a great opportunity for diversification through all kinds of sectors. And that's so, we're diversifying our own workforce through our engagement in space and other things just for those reasons.
Diversity and inclusion is an important part of the mission statement of New Mexico State University. And just show how that ties in. Probably 7 years ago, we competed in the University Nanosat program, which is another AFRL project. There were 87 students who touched that project in some way. 51% were minority students, 28% were women. And right now, from that project, 5 are working as either contractors or civilian employees at AFRL. 1 is at Sandia and 2 are at Los Alamos. So that really shows you how the other thing about bringing in small businesses is to generate the workforce that's needed to support them. And projects that AFRL is doing with the University Nanosat program or now with the Hyperspace Challenge is really helping us to make that workforce available to companies who want to relocate in New Mexico.
Totally agree. From an AFRL perspective, I mean, we have a number of diversity and inclusion initiatives. And one of the things that I've really noticed this year is that people have started to talk about how diversity is a mission imperative, and that diversity is needed to help make us better at, out innovating our competitors and just being a better organization. And there's lots of, studies that show that. And so that was a big shift in thinking, I'd say, over the past 5 years, at least within the AFRL, that has been really positive, I think. So agree with everything else. And I think that that's very important to us as well.
Fantastic. On this positive note, I'd like to wrap up today's panel session and thank my esteemed panelists and my co-moderator, Myrriah. There's a lot of exciting things happening in New Mexico, and we really strive to continue to build those connections. So for the Canadian researchers, students, businesses on the line, please feel free to reach out to my office. You can find me. I've got my email profile active on the app. As mentioned by the panelists on the line, they'll be they'll welcome connecting with you and working to grow our connections further. Myrriah, any final thoughts?
I just want to give a special thanks to our panelists. As Dina said, there's some really exciting things going on here in New Mexico, and we hope that this inspires some future collaborations between our Canadian friends and New Mexico companies. So thank you all.
Thank you, merci.